Hi friends, in this one we're going to take a look at an exploration of how calculus, a concept from it, can be illuminated using geometry of a particular kind, a construction of graphs. That hopefully will enable us, in other words, to visualize an entire calculus process all at once. So what do I mean here? Take a look. Here's a pretty standard question. Okay, so the limit, and then t goes to positive infinity, and let's say tan inverse of 1 over t. This is a limit question from calculus, and often you're told if you can, for example, do this with variable substitution. So then this is what we do often. We set u equal to 1 over t, and because we're switching from, let's say, t as the variable to u as the variable, then this thing gets recreated along the lines of the limit as u goes to 0, and then here you have tangent inverse of just u. This is tangent inverse here, right, with a little negative 1 up there. And suddenly this becomes u, but this was t. Why is it like this? What's happening here? So what I'm going to do is I'm going to do two graphs, one that represents u equals 1 over t, and one that represents tangent inverse of u, and I'm going to make a connection between the two to try to help us understand better how this thing here, let me emphasize this, how this thing here just becomes this thing here. There's stuff going on, a connection between the two graphs for the tangent inverse and also 1 over t. So a way to think about this is as follows. Take a look. First, begin with a graph of tangent inverse of u. So begin with that graph. Let me do that now, okay? I'm going to put these in here. So tangent inverse of u, I'm going to use my meter stick here. All right, let's see here. So tangent inverse of u, I'm going to put that up here. So this is going to be the u-axis in this context right here. And the outputs for the tangent inverse, I'm going to put on the vertical axis. So those will go about here, like this. All right. Now, take a look here at the following. Let's make a picture of the tangent inverse of u function. I'm going to focus only on this quadrant here. The rest of it doesn't matter. So within this quadrant, tangent inverse of u, it looks like the following pretty much, okay? It kind of looks like this. Remember, it's generated by taking one branch of the tangent function and mirroring across y equals x. This up here, let me see, so this up here, if you recall, this approaches the following, right? So let me, okay, let me mark this up this way. So you need two hands for this, okay, like this. This is the horizontal asymptote. This horizontal asymptote, this is a value. The value is pi over 2. All right, so that takes care of this part, but then where does u equals 1 over t fit into this picture? Well, remember, u is the output from doing 1 over t, which means since this is the u-axis, then, and this is to represent now an output from 1 over t, where is the t-axis? We can construct the t-axis here as follows. Take a look, just draw it straight down basically, this way. Let me show you. Okay? Why not? Like this. This is going to be the t-axis now, going straight down. And this is t now, like this. Then where within this construction does 1 over t appear? Well, if this is the t-axis and this is the u-axis, then 1 over t, that pretty much would look something like, say, this. You see? Like that. That's 1 over t now. So here, let me label it. So this is 1 over t in this construction. How does this help us with all of this, right? Using this picture. So take a look at a process here. Grab a point somewhere. So let's see. Maybe I'll do this with a different color. Yeah, let's use this one. So this is like a particular value of t. We'll call it t sub 0. When that goes in, it bounces off the graph, and it produces 1 over t, which is, as you can see, also equal to u. So that means this here, this value that's output is 1 over t sub 0, but that's also equal to u. And that then gets fed into the inverse tangent function next. So it's going to bounce off the graph here, basically, and then get output over here. You see? So this goes in. Well, let's say this is A, This is B. We'll call this C, ABC, call this D, and call this E right here. See, that's the output. How does this help with limits? Because now we can visualize everything that this is saying. Think about it. Limit as u goes to 0 of tangent inverse of 0. And then this is u equals 1 over t. So we can now write this as follows. Take a look. We can do the limit as t goes to positive infinity. That's like saying t is going to positive infinity straight down here. So let me emphasize, right? It's going towards positive infinity this way. Then look at what happens, right? As t goes down this way, then if you grab another value of t, you're going to hit this curve, you're going to bounce off, and then you're going to come over to the u-axis right here. That's going to get bounced off the inverse tangent of u, which then gets lastly output over here. Right, so if this t bounces off to here, right? This next t, we'll call it t sub 1, is just a particular value of t. So it's going to go from here to here. We'll call this, let's see, 1, step 2, step 3 is over here, and then say, well, it's going through the curve, but let's skip that. Let's just make this 4 here. So 1, 2, 3, and then 4. So as t is going towards positive infinity, this here, u, which is 1 over t, this is going towards u equals 0 here. Like this, you see, u is going towards 0, and then these values are going towards 0 also. In other words, they're moving down in this direction, correct? So you can say the following then. The limit as t goes to positive infinity of this part alone, 1 over t, well, that's just equal to t is going to positive infinity, so this is equal to 0. And then, take a look. You can say something like the limit as u goes to 0, remember, 1 over t, that produces your u values right here, you see? So the u is going towards 0 right here. This is u going towards 0. Right, so limit as u goes to 0 of tangent inverse of u, well, these values then along this axis are going towards 0 also, so this is ultimately equal to 0. So you can use a graph construction like this. It's not shown in the vast majority of books to really dig into the meaning of the symbols in a geometric way. We can also apply it not just in this situation. Let me show you one more example. So let's think about this. The limit, say, as t approaches 0 from the right side of tan inverse, let's see, of 1 over t, right? The question is, what does this equal? Can the construction here using the graphs assist us in finding the answer? That's what we want to answer. So let's think about this a little bit, okay? Well, let's see. Take a look. So t is going towards 0. In this construction, let's see, I'm going to use a different color. I got to differentiate. So here, t going towards 0, it means like t is moving this way, okay? T is moving towards 0 along this t-axis, you see? It's moving towards 0 here. As that happens, look at this output. Follow the white line. It goes this way. It bounces. That gives you a value of u. And then bounces. And then it bounces all the way to here. So beginning from here, this is a particular value of t. Bounce off the curve. That gives you u equals 1 over t. That gets fed into the inverse tangent, which gets output here. Just follow the arrows. Now look very carefully. What happens when we get closer still to t equals 0, right? Because you see t is approaching 0 from the right side. From the right side here means this way, okay? Because the t-axis is oriented vertically. So here, take a look. Right? Imagine a value of t, like this value of t, right here, that's very close to 0. So then, look, trace the white line carefully, okay? So it's going to bounce off the curve, right? It's going to get fed into the inverse tangent, and it's going to get output all the way right here. You see this? So as t goes towards 0, follow these. 1, 2, 3 gets output here. As t gets closer to 0, 1, 2, 3. This is moving towards the horizontal asymptote up here. You see this? Right? Because this gets output first, this gets output second. So these are moving towards the horizontal asymptote, which means, since that's the case, then you can say the limit of the tangent inverse of 1 over t as t approaches 0, that would be equal to pi over 2, purely by this kind of geometric reasoning and the connection between the graphs. That's all I wanted to say here. I hope this is insightful and interesting to you. Please leave a like, please subscribe. I read the feedback for comments and such. I'll see you in another video.